Welcome to springlib.
To conduct a hypothesis test to determine if the true proportion of people in the town suffering from depression or a depressive illness is lower than the percent in the general adult population in the country, we'll perform a one-sample proportion test. So let's set up our hypotheses. Our null hypothesis is that the true proportion of people in the town suffering from depression or depressive illness is equal to or higher than 10.9%. So I'm going to say p hat is greater than or equal to 0.109, and our alternative hypothesis is that p hat is less than 0.109. We use the significance of 0.05. We know our sample size is 100. The number of people suffering from depression or depressive illness in the sample is 8, and the population proportion from the organization's article, which I'll just call P, is 0.109. To conduct the hypothesis test, we'll calculate the test statistics, which will be a z-score and a p-value. The z-score is calculated as x minus np over the square root of n times p times 1 minus p. And so that would be 8 minus 100 times 0.109 over the square root of 100 times 0.109 times 1 minus 0.109. Into a calculator. And we get a negative 0.93. Using a standard normal distribution table or statistical software, we can find the p-value corresponding to a z-score of negative 0.93. The p-value represents the probability of observing a sample proportion as extreme as the one we have if the null hypothesis is true. The p-value is 0.1762. And since this p-value is larger than our significance level of 0.05, we fail to reject the null hypothesis. So the conclusion would be that based on the sample data and the performed hypothesis test, we do not have sufficient evidence to conclude that the true proportion of people in the town suffering from depression or a depressive illness is lower than the percent in the general adult population in the country.